Hello, Professor. My name is Derek Lundy, and I'm here with Colin Willis, and this is our final project presentation for PC Build. So PC Builds manages user-submitted PC builds that contain all parts and prices associated with the PC build. For example, CPU name and price, GPU name and price, motherboard name and price, etc.
Okay, so the project objectives. The project objective was to create a dynamic enterprise web application that manages a product using CRUD functionality. The application must be deployed to a cloud, and the application must implement DevOps support. And our functional overview, our application includes register functionality, login functionality. You can view all the builds that are submitted to the website. You can view your specific builds. You can create a build. You can edit your build that you've already posted. You can delete one of your builds, and you can log out.
For the technical design decisions, overview, and implementation approach, PC Builds is a dynamic web application built with Spring Boot and Timeleaf. PC Builds was designed using the n-layer architecture MVC design pattern and leverages a MySQL database via the layers of n-layer to securely perform CRUD functions on the application's data. The application is hosted on the Heroku cloud platform. And then for our chosen framework, we have Spring Boot 2.5.5. We use the Java 11 version of the programming language. Heroku is our final cloud provider. The database type is relational MySQL, and that's the version. The front end, Timeleaf, and we also use Bootstrap to do the CSS, and the project repository is GitHub.
Okay. So for the user experience, here we have the login form, which is a very basic Bootstrap login form. We have the register form. And then once logged in or registered, it brings you to the homepage where you can view all of the builds that have been submitted. So for example, you can see test build 1 and test build 2 with their prices underneath and the username of the user who posted that build. Okay. You can also add a build. So here's our add build form. It's pretty long, so we didn't get the whole thing in the picture. But for example, you do like the build name, and then you put an image URL, a case name and a case price, and a motherboard name and a motherboard price, etc. Okay, and then you can view your posted builds where you can edit or delete the build. So yeah, you can only do that to the ones that you have posted specifically. And then you can view a build posted by a user. So then you can see all the details of the build in this little table right here with the case name, motherboard name, and all the prices. And for the storage, you can see we have a type. So it's SSD. When you're creating it, you can choose to do SSD or HDD. And then it has a total price up at the top.
So for the project limitations, bugs, and known issues, inputs throughout the application do not protect against SQL injection, SQL-related characters. A bug is none of the fields for creating a build are required. No filtering and sorting builds is available, and you cannot save a draft of a build. And a final bug that we have is the price is not formatted correctly, and nor do they contain symbols in some pages.
Okay, for a cloud platform and DevOps support, we implemented a CI/CD pipeline monitoring. Our platform is Heroku, and we implemented logging. So Heroku's CI/CD pipeline was connected to a GitHub repository for automatic code deployments. We used SLF4J to generate tracer and info logs in Spring Boot. And we utilized Uptime Robot to monitor the application. So if it goes down, it'll send us an email. And when it goes back up, it'll send us an email. So we'll be alerted. And that's about it for the presentation. We'll attach another video for the demo of the application. Heroku's services are down right now, so we'll just attach our previous video. Yeah, thank you. Hello, Professor. This is Colin Willis and Derek Lundy, and today we'll be demonstrating our DevOps functionality in our cloud application. Our application is deployed to Heroku. And to deploy it, we hooked up our GitHub repository that houses all of our code right here to our Heroku application. So it automatically pulls our code, builds it, and deploys it. And we'll get into the CI/CD pipeline a little bit later. But if we go over to resources, we implemented the JAWSDB MySQL database, and we imported our local schema using MySQL Workbench and the JAWSDB connection properties, and we pushed that schema up to the JAWSDB. So now we can have access to all of our data. So if we go into the code right here, you can see that in our applications.property file, we have all of our JAWSDB connection properties. So that allows our application to connect to that database. And in order for us to get the application running on Heroku, we had to add two different files. So the system.properties file sets our Java runtime version. So we went with 15. And then we also had to add a proc file, which basically just tells Heroku how to run the application. And now Derek's gonna take it over and walk us through our logging in our application.
So in the pom.xml, we have to add a dependency. It's the Spring Boot Starter AOP. And if we hop over to the com.gcu.util package, the AOP configuration is where we used that dependency. And you could see that it basically just structures what the log statements are going to look like on the tracer end. And then the actual tracer itself is a separate bean, and that's this file right here. And it extends the abstract monitoring interceptor, and we just have methods in here. Basically what this is going to do is globally, every time a method is executed, it will have a beginning and end, and it's structured how we want it to get spat out in the log statements right here. And in the XML logback Spring XML file, this also has further parameters and basically how the logging structure is going to be formatted in our log files right here, all defined. So then in the log folder, there's going to be a log folder that basically gets produced if it doesn't already exist. And so we will take a look at those logs in the Heroku app later. So
Okay. So if we go into the application, we can go ahead and produce some logs. So we'll log in. Okay. So if we go back to our Heroku application, we can go to more and we can go view logs. And you can see that our tracer is tracing the different methods that were called. So we have the business service doing the login functionality, the find all functionality. So yeah, that's our log files. So now we're going to demonstrate our CI/CD pipeline. So if I go into our code, currently, let me log out really quick. You can see that the login page has a login title. We'll change that. So I'll change login to build pipeline, save it, and let me open up GitHub desktop. We'll do pipeline. Okay, commit that to the master, push that. Okay, so if we go to our pipeline within Heroku, okay, you can see that it's currently building the application. So I'll go ahead and pause the recording and we'll come back when it's done. Okay, the build just finished and you can see a release version 12. So if we go back to our website, I'm going to close that actually, and I'm going to go into the actual application to relaunch it. Okay. So now you can see our title on the page is build pipeline. So the build pipeline is automatically deploying our application every time we push a new update to GitHub. Okay, so now I'm going to pass it off to Derek, and he's going to talk about the monitoring in our application.
All right, so we'll go and we have the website Uptime Robot hooked up to this for monitoring. So basically, we take the URL, that URL right there where it's pcbuilds.herokuapp.com, and we just put it into a new monitor. And every 5 minutes, which is the free version that's available for this or free setting, it will just check every 5 minutes to see if our website is up and running. So what we can do is we can open up the command prompt and we'll use the Heroku CLI. And if we put in a specific command, this will make it so that way there's no machines that are running our application. And with the web equals 0, what this is essentially going to do is make it so that way 0 machines are running our service. And so now we're going to wait for the 5 minutes. We're going to put the video on pause and we'll come back when Uptime Robot updates for us. And as you can see, Uptime Robot now says that our Heroku app is down currently. And Uptime Robot actually sent us the email to notify us for the monitoring to be helpful. So now it says that it's down. And we can actually go to the PC Builds website in its current state right now to show what that looks like. And so this is what is being monitored for application error type status stuff. And so then we can go back to the command prompt and we can turn our application back on. We'll use that same command, but we just need to have a web equals 1. So now the machine's going to use is going to be turned back on. And Uptime Robot is going to take another 5 minutes. Is for the 5 minute interval to show us that our application is back up. So we will pause the video and show that when it is back up. And as you can see, Uptime Robot now says that our application is back online, and let's go and prove it really quick. So you can open up the app, and now it's back up. And so that takes care of the monitoring, and that completes our project video and covering all of the DevOps functionality in our cloud. And thank you for watching.
Thank you, Professor.